So for contact lens recap, Randolph requested clarification. Toric contact lens that I required, by the way, have another after this. Um, we'll do the soft toric fitting next week. As now for when it comes to toric, it's available to compare with Sphere. Even with Sphere, RX may not be available. It's even worse when it comes to toric. Toric is harder. So meaning to say, other distributor may need more time to order from abroad. So there's what we call the lead time. So others will take months, others 3 weeks. That's why I said any as long as it is toric. Okay? Because what we're looking at toric, of course, other than the reference mark that we will see, is the behavior of the contact lens whenever you have a toric contact lens, because it does not behave the same way as a sphere. A sphere, even if it rotates, will have the same power. That's why we don't have usual problem when it's sphere. Meaning to say, if I have a -5, even if it rotates um 360, 180, 70 degrees rotation, it does not matter because the power is the same all across. But when it comes to toric contact lens, you know that there's a power meridian and an axis meridian. That's why it's very essential that we also understand that when prescribing soft toric. Are we clear so far? We'll discuss more on toric next week. Okay? So far so good?
Yes po, Doc.
Okay, thank you, thank you. All right. So, based on the copy that you all have, okay, I think there you go. This is something that you are to do, right? So, you will do this next week. As we again, heads up, kindly tell Randolph, tell Section Dog that as I've said, every time we meet, we will have quiz for lecture. We will have that also on a Saturday. For those who have lab only, you will have your computation and the fitting, which is every Saturday. Okay? So that you don't ask, are we going to have a quiz this Saturday, next Saturday, every Saturday? It's already announced. Okay? All right. So this is something that you are to document, right? You have your placement method, 5 4 3 2 1, removal technique, 5 4 3 2 1. What is that? Highest rate is 5, the least is 1. Okay? So this is your 5 4 3 2 1. So moving forward, this is what we're going to use. So when you try to fit, this is what you're going to get. First time is 5, second time is 4, third time is 3. So far, so clear? This one will be the basis of our scoring. Moving forward, next Saturday. Kindly tell Section Dog Randolph. Copy?
Yes, sir. Yep.
Oh, okay, gotcha. Okay. So this is to be documented. So you have your method one by placing the contact lens onto the cornea straight. And then this is by looking up through the sclera. This is looking nasally or inward through sclera again. And then this is looking down through sclera. Then the removal, of course, pinching, one, look up, and then the third one is straight onto the cornea. Correct? So we have three ways. But here we only have the two methods, but we do three methods. Now, of course, locating and recentering soft contact lens, which I've said earlier, when it comes to contact lens, sometimes it's misplaced or decentered or uh, moved inferiorly, superiorly, nasally, temporally, especially for RGP. You might be looking for the RGP because RGP is smaller. So sometimes it goes all the way to the inferior that you cannot, it's not going to be visible. So what you do is retract the eyelid or ask the patient to look. If it's inferiorly, look up. Then as you look up, you can see the RGP is located inferiorly. So it's on the sclera. So that's one thing you need to understand. Okay. So all you gotta do for soft, which is a lot easier because the diameter is a lot bigger. So almost the same thing, but you can see it right away if it's displaced. All you gotta do is drag it. So heads up, the only thing that you can drag is soft contact lens. RGP, you cannot drag. You cannot put it through uh, via sclera. So you have to really place it onto the cornea right away because you cannot drag it. Since it's hard, it can create scratches and it will scratch your cornea, something that we don't want. Okay, but for soft contact lens, because of its material and its property, it's so soft, it doesn't damage the cornea because again, it's soft, it's pliable, plus the material with water content obviously does not have uh, much of a mechanical effect on the cornea. That's why we can drag it. Okay, so all you got to do is drag it to the center, and then that's it. It's the same way from the center. When you're removing it, you drag it to the sclera, right? Whether inferiorly, superiorly, or temporally. So that's what you do. Okay. Any questions on that? No questions. Clarifications? None. Are we good? All right. Now, let's have the soft contact lens design. When it comes to design, we understand that for RGP, the design matters a lot because this is your bicurve, tricurve, multicurve. And for soft contact lens, the design does not matter much when it comes to the curves. But of course, there are also design such as there are manufacturers that creates contact lens through lathing, molding, or combination. And there are others that are thicker than the other manufacturer. I remember one time we gave there's this lens maker and they gave samples of their contact lens. The first thing that our students, well, by observation, said that this contact lens is a lot thicker than what they use. So there's more lens awareness, meaning to say it's less comfortable. It's they can feel that they are wearing other than it is actually a foreign body. Of course, obviously you can feel that you're wearing something, but when it's thicker, you'd feel it more. So they feel the edges. They not only the thickness but also the design of your axial edge lift or the radial edge, wherein it could be round, 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 square, square, square. So that's as for design. That's why it's assessed as written here, a good lens design is paramount importance for a good lens performance. So the better the lens design, the better the fit, the better the feel. That's why. Do they differ? Of course. It's just like saying again, from a Toyota to Mitsubishi to Rolls Royce. They may be all cars, but they don't have the same feel when you drive it. Are we clear so far? Any questions? Any questions so far?
None po, Doc.
Okay, gotcha. All right. So again, for competency, the student should be able to utilize pertinent information like the K reading, refraction in design. Of course, we know that. Be familiar with different soft contact lens parameters such as base curve, lens diameter, power, center thickness, and water content. And know and understand the influence of these parameters on the lens behavior in C2. In the same when wearing. Okay, so let's go through it. Lens diameter. How do we get the lens diameter? It's by getting the HVID, right? So later we'll further discuss that. It's HVID plus 2 to 2.5 for soft contact lens. For RGP, it's the reverse, which is minus 2 to 2.5. Always understand that a soft contact lens is always larger diameter. Uh, an RGP, on the other hand, is smaller, therefore, you have to use the formula HPID minus 2 to 2.5. As for the base curve, we have your K reading, and based on the K reading, you have your horizontal and vertical. And based on the horizontal and vertical, you look for whichever is flattest, right? So, for example, you have 44 and 45. Obviously, 44 as the flatter. Okay, 44, 45. Assuming this is 44, 45. At 180 and 90. So obviously, this is the flatter. Okay, what you do is as simple as 1.3375, which is the index of refraction of your ophthalmometer or keratometer. And then you have the air. That's why there's air, which is 1.0. That's the air. Okay, multiplied to 1,000, multiplied 1,000 because it's in millimeters, right? So in effect, you have 337.5 divided by the flattest K, which is 44. That should give you 7 point. Compute, guys. 37.5 divided by 7 point. Uh, am I still heard? Randolph.
Yes, Doc.
Okay. Uh, I have a question here. Is my question clear, or was my discussion clear enough, or you're not getting it?
It's clear naman, Doc.
Okay. So what's the answer? Three.
7.67.
What? Joyce. There you go. Joyce, are there? 7
Yung,
point.
yung final answer na po, Doc,
Yes. Yes.
7.7 po.
7.7 because it's
67 po.
7.67, right? And then you round. That's why 7.67. But don't round off first. This is 67 based on this formula. But remember, there's a fit factor. How much is your fit factor, Joyce?
Point 7 po,
Point
Doc.
0.7. Then add 0.7. That should give you 8 point.
8.37 po.
Okay, so 8.4. Correct? Clear? So this is now your base curve. Okay. Are we clear? Gotcha. Gotcha. The red one. Good, good, good. So far, so good. Okay, let's go back. Okay. Okay. Let's go back. Why do I have to do this? Okay. Okay. What happened? Okay. Okay. You can see my screen, right?
Yes po, Doc.
Yes, thanks to you, Joyce. Joyce, I need you to be talking to me because other than I need feedback. I need to know whether you're seeing my screen. All right. So far we're good with base curve, then lens power, of course. Why is it like that every time I exit? Anywho, okay. As for lens power, remember SR, which is spectacle refraction, subjective refraction, or your manifest refraction. This is your SR. Over 1, which is air, minus VD, which is your vertex distance, times SR, which is spectacle refraction, or subjective refraction, or manifest refraction. Okay, so far so good. And with a premise that we only do this when we are at plus or minus 4. So if it's not 4, such as 3.75, then no need for lens power because effective power is not taking effect. So no need to compute whatever is the spectacle refraction. That's what you order for contact lens. So far, so clear. Are we clear on this?
Doc,
Any
may
questions?
question lang po
Go
ako.
ahead. Go ahead. Go ahead. Let's
Paano po
go.
kapag paano po kapag may cylinder po? Ta-
Oh,
um
okay. For example, minus 2 combined minus 3, axis 180. What do you do? Of course, first deal with the sphere. Do I do lens power here?
no po.
No, because it's not 4. Remember before, plus or minus. Okay. How about 3? Is it 4? Lizelle, is this 4?
Hindi po.
So are you going to do it or not?
Hindi ko po alam.
Okay, you add them. As simple as that. You add them. This should be compound. So as you can see, I have a minus 5 right away. How did I come up with that? 2 plus 3 is 5. They're both minus. That's why it's compound. So in effect, another way to do it, which is the cross. So you would notice minus 2 on both meridians, but this is axis 180, meaning to say 180 will get 0, while this one will get minus 3. So 90 will get minus 5. So on the 90th, I will have to compute. So I have minus 5, then 1 minus 0.012, which is our vertex distance, especially for Asian, unless otherwise. If I give, I would say 13, 14, 15. Okay, so yes. I already have trauma because someone was like doing a minor bird when I'm talking. They're also like talking and like imitating me. So, anyways, let's move forward. I'm just having that in my thoughts. Like I can hear myself through someone, you know, being my minor bird. Do you know what a minor bird is? The minor bird is someone who imitates when you say something. If you say hello, the minor bird say hello. Yes, that's what's going on in my mind right now, and I can't take it away because it's like recorded in my brain. Good thing my brain is recording. It will never forget. There you go. So, are we clear so far? Any
Dok,
questions?
can we have one example po ng solving yan? Kung okay lang po.
Oh, sure, of course. All right,
Thank you
let's do
po.
this. Let's do that. Minus 2 combined minus 3. So, what do? So, you don't deal with that. So, automatically, your final answer would be minus 2. So, the next question is what is your cylinder? Correct? Based on that. Correct? So, how do you compute for that? Again, technically, it's so easy. You have a minus 5, right? So, just do this. Okay, do it with me, Lizelle. Minus 5, and then here 1, minus VD. Again, I am not giving that, so 0.012 times minus 5. So what do you do first, Lizelle? First thing, you do this. 0, if you have a calculator or you want to do it longhand, it's okay. 0.012 times minus 5. How much is that?
Minus 0.06 po.
Okay. So we said minus 5 over 1 minus 0.012 times minus 5. So your answer, how much is your answer again? Sorry, minus
0.06 po.
0.06. And then bring down the 1. 1 minus 0.6 should be
1.06.
1.06. Very good. Now you do minus 5 divided by 1.06. Minus
Minus,
5 minus what?
minus 4.72 po.
Minus 4.72. Okay. So, with the premise, let's check it first. With the premise, this is now the Rx. Extract from this, because this is compound, is the minus 2. Correct? So, minus 2. That should leave you with how much?
Um,
Or
minus 2,
7.
minus 2.72 po.
There you go.
Ay,
Then you have, because this is 72. Is that what it is?
opo.
Okay. So, in effect, you have 5, right? I'm not gonna make it so complicated for you because we have increments of 25, correct? So you would notice now the Rx should be the final Rx based on your computation is now minus 2. This is the final answer, meaning to say this is your final Rx as you order a contact lens minus 2 combined minus 2.75.
So,
Axis 180,
Doc, so
correct?
hindi po siya magiging minus 2.5?
Um, Technically, as I've said, if you see that there's a reduction, unless otherwise, when by computation this remain at 3, then you use the least minus because you already see that there's already a reduction, which is 5. Actually, there is an estimation. 4 to 5 plus or minus will have a reduction or addition of 0.25. So I can give you an estimation as it goes higher. 650 to 7 should give you about 50. And it goes higher and higher. 75, 1. As the higher the power, the higher the difference. Is that
Doc,
clear enough for you?
for
And
clarification
then,
lang po, if ano po, if nagstay po yung answer, ibig sabihin po, dun lang po gagamitin yung lowest minus highest plus. Pero pag may changes po,
actually, yes, yes. But technically, this is, I hope section D is also here. For reference, you would notice a 0.25 is actually negligible. So in the real practice, whether it's a little higher than 25 or lower than 25, this is still accepted because the negligible astigmatism is up to 75. So this is more or less accepted by the patient. So a little changes like that, a little over 25, that will be accepted. But if you go beyond, which is about 50, like 50 is already felt, 75 is also felt according to the patient's sensitivity. So meaning to say, a little over 50 is something that is felt by the patient already. So not to mention, these things that we're doing in actuality is something you don't need to do because again every manufacturer will come up with guideline. So their fitting guide, called the fitting guide, is already a way to make it easier for practitioners to order even without going through the computations. So moving forward, you know that this is something that you need to compute for the sake of for board exam specifically, because you need to be computing. Unless you'll be computing in your practice, you can also do that. So you would notice, as you mentioned earlier, so when do I do? We always do the least minus. This is no brainer. We always do the least minus. Okay? In giving RX, I'd rather give the least minus and the highest plus. Okay? This is the general rule. So when you say general rule, Lizelle, what does that mean to you? Are
It
you gonna do
applies
that?
to all.
Huh?
Ano po ulit tanong ko, Doc?
What is general rule for you?
It applies to all po.
You will apply all the time to everyone. Correct?
Opo.
So that is your general rule. Always least minus highest plus. So your question is, for example, in the board exam, you would notice you have a -2 answer, a -2.25 answer, a -3.25. Should you have something like that, then you have to compute. And by computation, you would know whether you are using the least minus, because it's also based on your computation. Are we clear so far? Lizelle, are you clear so far? Is that clear enough?
Wait lang po, Doc. Last na po. So, balik, kailan na po gagamitin yung ano,
All the time,
i-round
all
down?
the time, all the time, all the time, all the time, all the
Yung, for,
time.
yung ano po, yung i-round
You
up na
have your
point
point
25.
7. Yes, it's all the time, all the time. Always least minus all the time. So, in a nutshell, all the time, all the time, all the time. So, as you can see, you have a 72, right? So, you would notice there's a reduction. Instead of using 75, you can use 50. You can also use that. That's why I said generally, all the time. You can use 5. You can also use 5. So, it's either you use 5 or you use, again, if you see that there's a reduction, wherein of course the real optics there is, as I've said, there is what you call negligible, meaning to say acceptable. So whether there's a range, whether you use 5, it's gonna be good. If you use 75 round coming from 3, it became 275. If you use this is gonna be good. If it ends at if you use the 250, then you have minus 250. It's still gonna be good.
So, for computation po, Doc, for example po, ang na-compute ko po ay 2.72.
So if you
Magiging
use
2.5
if
po
you
ba siya or
use
2.75?
what do you think? Based on what
Depende.
I've been talking about, like over and over, what am I saying?
It depends. Ang pagkakaintindi ko po kasi, parang kung mas mababa po yung 275 kaysa po sa RX, mag-go po sa 275. Pero pag mas mataas po yung 2.72 sa RX, gagawin ko pong 2.5. Saka ko lang po gagawin. Tama po ba, Dok?
Okay. So to make it yes, to make it easier, as I've said, let's make it a range. How about that, Lizelle? It's a range. You may use the 50 or the least minus at all times. Or if you notice that there is no difference when you're computing, that alone is something that you have to think of. Coming from at -2 and 3, which is -5 in effect, and if this is still 3, then most likely you have to reduce, correct? By computation. Is that correct? Because
Opo.
if you compute using the 75 and it ends with still 3, then most likely you would want to give the least minus. Do you understand what I'm saying?
Opo.
I hope we're clear on that. But if should you give like the same, what's gonna happen? In reality, actually, others are even doing the same thing. So it's just the tolerance. In if I am to be more strict, I would just say that you should lower it. Okay? You should lower it if I am to be strict. Correct? Because I am always under the general rule wherein giving minus, I have to give the least. If giving plus, I need to go maximum. Correct? But understanding the behavior of your binocular vision. If this creates more ISO, I will reduce my minus. If this create EXO, I will reduce my plus. Do you understand binocular vision? Lizelle.
Opo.
Is it clear so far? So it doesn't stop here. It doesn't stop in your computation. Part of you still have to correlate your binocular vision. If a patient, but of course, generally always give the least minus and the highest plus. Correct?
Opo.
Yeah. Is this clear enough? So when in doubt, always use this. So should I use a 75 over 50? Well, if I am to, because it's 72. So when in doubt, I always use this. So what should I give? I would always give the 5 because I would always go for the least. Does that make sense to you?
Okay po, Doc. Thank you po.
All right. When in doubt, always give the least minus highest plus. Okay? Because it's always better for us to understand not only the RX but also the behavior when it comes to the prismatic effect or the binocularity, whether it will induce esophoria or exophoria. Okay? If this or if this creates more ESO because of high minus, because high minus creates more ESO, then I am to use the least minus. That's why you always use the least minus because it will also create convergence. And then when it comes to high plus, we always give high plus because we're divergent that far. But if the patient is already exophoric or if the patient is already exotropic, so you give more plus, this one will induce more exo. So in that, you have to understand, should I give highest plus? That's where your premise will be something to consider. Because if I have an exo patient and the patient is presbyopic, I always give plus lenses, right? Because this is for reading, called the reading ad. So if the patient's already exo and I give, assuming I gave him ad 3 and the patient is already 10 exo for near, this is near, then most likely if by doing the binocular and this created a 20 exo, then I would think of lowering the plus. Do you understand what I'm saying?
Opo, Doc.
This is beyond computation. This is now correlation, which I'm sure you already know, correct? Because you're done with binocular vision, right?
Opo, Doc.
Okay, good. Any more questions from the others? Any more questions from the others? Okay. So, am I to assume that we don't have questions anymore? I want Joyce back. I need someone to talk to. Joyce or Randolph
Yes po,
or
Doc.
Randale. Yeah, go ahead. Are we clear so far? Do you see any comments there, like asking for questions? Can you be
Okay
my
naman po, Doc.
eyes? Okay, no more questions. No more. All right. All right. Let's go. Let's carry on. So that's for lens power. Now, water content. What did we talk about? Water content. Water content. Joyce, do you remember water content? What is important about water content?
As far as I remember po, Doc, sa water content po, more water content, more permeable po. For
100%.
yes
Very
po.
good.
Pag po mas mababang water content, less po yung permeability po.
Very good. Very good. So that's the water content. How about the center thickness? What do you remember about center thickness?
Dock center thickness
Very
also
good.
affects the oxygen permeability. The thicker it is,
Very good.
the less oxygen gets into the cornea.
Okay, is it permeability or transmissibility?
Uh, Transmissibility, sorry.
Okay, okay. No, no worries. So you get give yourselves points because it will be for exemption, right? So keep recording. Of course, it will carry on all the way to finals. All right, very good, Randolph. Very good. So the thickness matters. Why? Because the thicker the lens, the harder the transmissibility. But it's always with. That's why you are partly correct, Randolph, because it's permeability over transmissibility. Meaning to say they always go together. The permeability, transmissibility. It's a coefficient of decay, diffusion, and solubility over thickness, which is your transmissibility. Very good so far. Very good. So that's why water content is essential, center thickness is essential. So the higher the power, the thicker the lens. Correct?
Yes, Doc.
All right, gotcha, gotcha. So this is an example of your base curve. So this is how you do without the fit factor. You're just getting the radius of curvature. Correct, Randolph? So meaning to say, when you say radius of curvature, you are just basing it from the dioptric power to a radius of curvature that should give you how curved it is using a keratometer. Now, if you use the fit factor for soft contact lens, that is now referring to the base curve. So that's the minor difference. Are we clear, Randolph? So if you don't put the fit factor, that is just your radius of curvature. But when it comes to RGP, your radius of curvature or this computation leads to the base curve right away without fit factor. Anyways, I'll explain that more next sem. So far, so good. Are we good so far?
Yes, Doc.
All right, now, as you can see, however, most soft contact lenses come only in few base curves because, again, soft contact lens, when it comes to behavior, it's more forgiving because it conforms to the shape of the cornea. It's so pliable, it's so soft, it's so flexible that it takes the shape of the cornea. As simple as that. So that's why it's not that very strict when it comes to fitting because whether it's with different base curve, you can still give it to the patient because again, it's more forgiving. Okay? So how to select base curve? We already know how it's done. We just use the flatter. That's why it says here, when in doubt, fit a flatter base curve. Always, just like what we used earlier. When in doubt, always use the general rule. The least minus and the highest plus. That's why you need that. So this always fit the flatter than flat. Unless your intention, Randolph, is to fit steeper, then you use the steep K reading. Is that clear? Because if I am to choose between flat cornea, because remember you have your horizontal and vertical, the flatter portion of the cornea, which is probably in by example, I have 44 and 45, 180, 90. It means at 180, it's flattest. So I will use that, the 44, instead of 45. Unless I want my fit to be steeper. Clear?
Yes, Doc.
All right. And then as for lens power, as you can see, this is our lens formula, wherein it's F, which is your S, which is your subjective refraction, spectacle refraction, or your manifest refraction over 1, which is the air, minus the vertex distance times your subjective refraction or spectacle. Okay, that should give you this. That's why in our example, minus 4.71, you can use 75 basing on the least minus. I hope this is clear now, Randolph. Is it clear now? So I can use 75, I can have a minus 475, or I can even give a minus 450. Correct? Can I give a minus 450? If I would use the least minus. And if that's available, I'd give that. I'd give that to you. If your RX is minus 5, Randolph, I'll give you minus 450. I can do that. I will do that. Will that be a problem? No. Randolph, are we clear?
Yes.
Yes. I hope everything is super clear, right? Okay. I always give the least minus. Okay. So again, this is your HVID, meaning to say HVID plus 2 to 2.5, that would be for soft contact lens. Okay. So our example here, if I have an HVID of 11.5 plus 2, how much would that be? Or if you use plus 2.5, 2.25, because it's a range, meaning to say I can, it doesn't say state here that I can use 2.25. But since it's a range from 2 to 2.5, it means I can also use a factor 2.25 addition. And that should be my lens diameter. So far, so clear, Randolph?
Yes, Doc.
Yes. Okay. Now, for center thickness, as you can see, this is a range also. You have their standard thickness of 0.10 or 0.10. So everything that is above that, you might have a problem. Number one, with awareness, meaning to say when you're wearing it, you can feel it, it's thick. Number two is hypoxia, or vice versa. Maybe first concern is hypoxia, second is awareness. Are we clear? Are we clear so far?
Yes po, Doc.
Gotcha. Thank you, Zach. Now, water content. Of course, we explained that. Thanks, Joyce, for explaining the water content. The higher the water content, the more permeable. So we're talking about the material, okay, and the property inside the contact lens to compare with the thickness. Okay? So it's not the same. Thickness is transmissibility, material is permeability. Okay? So far, so good. And that's the end of our discussion. Unless you have any questions, I am ready to entertain. Go ahead. Any questions?
Doc.
Yes, yes, yes.
Yes, I
Hi,
just want to.
Irene. Hi.
Hi, Doc. I'm just wondering if you can explain to us again how to find the with the rule and against the rule
Okay.
astigmatism,
Surely,
and
surely.
also the how to find the if it's internal and, and external
Oh, for
and
sure, for
oblique.
sure. Sure, sure, sure. Let's do that. Okay. All right. I'm sharing again. Can you see it? Are you seeing it?
Yes,
My
Doc.
screen? All right. All right. Let's do it. Okay. First question of all the questions. So you said you want to know the with the rule against the rule, correct? Okay. So if I am to understand, this is 0, this is 180, correct? So if I am to see that this is a range, okay, so this one is my against the rule. Why would I say that this is against the rule? Two ways you can think of it. Okay. First, where is the location? Okay. Location of what? The power. Or where is the location of the axis? So if I am to understand, to make it easier, for me, I would always go for location of the power. Where it is greatest, the greatest curvature is where my reference for with the rule against the rule in oblique. Let's have this first. 0 to 30. Okay, 0 to 30 falls under horizontal, correct? And horizontal is your against the rule. So far, so clear? Are we good?
Yes, po.
Okay. Having said that, if my greatest curvature is at 0 to 30, so that would be 150 to 180. This falls under against the rule. Meaning to say the greatest curvature of my when it comes to astigmatism, right? Because we're talking about astigmatism here. The greatest curvature falls here, therefore it is against the rule. But if I would use axis, which is opposite of the power, meaning to say, if you give me an Rx of, let's say, minus 3 combined minus 2, axis 90. So 90 is the least, correct? Correct.
Yes, Doc.
So if this is axis 90, 90 means it's not too curved. Where is it more curved? 180. So it falls under against the rule. I say this again. First thing, by location, where is it greatest? Where is the curvature greatest? It's that the reference for you to know whether it's with the rule or against the rule. 0 to 30, 150 to 180 is the horizontal, which is against the rule. So, by locating where is it steepest, meaning to say where is it steepest, how would you know steep and flat? When you use at. Remember? For example, I have 44 at 180 and 43 at 90. Where is it flattest?
At 90 po.
Flattest at 90?
Ay, at 180 po.
Okay. Again, okay, let's clear this again. I have 47 at 90 and 44 at 180. Where is it flattest?
At 180.
Very good. So this is flattest. So therefore, my patient based on this alone is at 90, highest or steepest. Therefore, if it's 90 steepest, this is a with the rule. Correct?
Yes po.
All right. So based on looking at this alone, you would know right away whether it's with the rule or against the rule. Because based on my drawing earlier, so this is 0 to 30, 150 to 180. Correct? And then
Yes po.
I have a with the rule. So, meaning to say 31 to 59, that is oblique. Correct? Because this is 60 to 120. Correct? Do you follow?
Yes po.
All right. So, meaning to say, my oblique is now 121 to 149. This is my oblique. If my Rx says minus 3 combine minus 2, axis 130, what does it mean?
Oblique
Irene.
po.
All right. Oblique is the easiest. Why? Either ways, it's gonna be oblique, right? So once you see it, it's an automatic oblique because both oblique, unlike the horizontal and vertical. This you have to be keen. You have to understand. Is it horizontal, which is against the rule, or vertical, which is with the rule? As for oblique, that's the easiest. Correct?
Yes po.
Is that clear enough?
Yes, doc.
All right. As to your second question, when do you say that's internal, external? Okay. For example, give me an RX, any number.
Minus 3
Okay.
combined with minus 2.
Okay. Axis.
X is 180.
Okay, 180. Okay. By this alone, I have my total. This is the total. Okay. Remember the formula? I plus E equals T. Correct? Okay. So I already have this. Check. What is that? This one. So the next thing I need to know is this and this. I don't have that. But if I do my K reading, I will get this. Correct? So give me K reading. 40.
45
Okay.
at 90
At 90 and
and 47 at 180.
47 at 180. Very good. So you have a minus 2. Correct? So you have a minus 2 axis on the flattest, which is 90. So this is going to be axis 90. Correct? So now, the thing you need to do is to correlate your K reading as for your AC, corneal astigmatism, with the total astigmatism of the patient. Are they the same?
Yes po, Doc.
Are they the same?
Yes.
Is it a yes?
Yes.
You said this is axis 180.
Ay, 180.
Mm.
No po.
Oh, this is, you said,
N-
at
at
90,
90.
45, 47, 180. So steepest at 180, flattest at 90, therefore axis 90. Are they the same?
No po.
No, they're not the same. So that's how you correlate. So now you'd know that my internal must be something different from the external because I have axis 90, right? Maybe I have a 4 inside that is more of 90 that created a minus 2 axis 180, or more of 180 rather, to create a minus 2 180, because they're not the same, correct? Meaning to say, by logic, I'm looking at internal. So my question now is internal. I don't know the internal. Can I find out my internal? No, because I do not have the test to create that. But what I need is a barometer, uh, some sophisticated instrument to find my internal cornea, because there's an external cornea against an internal cornea. So you can use pachymetry, you can use barometry, you can use others to find out the measurement. But of course, we only have K reading, so we deduce, or we do the deduction method, correct? So because we have the external, but we don't have the internal. So we think of a number that would give me a total of minus 2, 180. Correct? And I'm looking at, probably inside, I have a minus 4. That would create a minus 2, 180. Because this one will cancel the 2, but then again, this is 90, not 180. And there's still a remnant of 2, 180. So internally, I am assuming there must be a minus 4 axis 180, because 2 and 2 should cancel out if it's the same. So it should be 0. But then again, my total astigmatism is not 0. Let's have another example to make it clearer or simpler. Okay, for example, I have a minus 2 diopter sphere, and my K reading is 44 and 45. Let's say at 180 and 90. That should give me minus 1, axis 180. So by looking at my AC alone, this is my external. Is it the same, Irene?
No po.
Why?
Because the AC is axis 180 and then there's no axis on the.
Very good. No, not only there's no axis, there's no astigmatism in my total. I got no astigmatism here. Correct?
Yes po.
I don't have astigmatism. So where is this minus 1? External. What happened to that? What do you think happened to that? What do you think happened to the external astigmatism? Anybody? It must be by logic. Go ahead. Someone wants to answer? Irene, you want to answer? Anyone?
I'm not sure po, Doc.
Okay. So what happened there? Okay, go ahead. Anyone raising their hands? Go ahead.
Doc, na-neutralize po siya ng
Very good. How?
hydrogen.
Huh?
Maybe, pwede po sa axis po.
Okay, axis 90 inside. Okay.
Opo.
Or, so meaning to say, Irene, there must be internal minus 1, axis 90, that canceled the astigmatism. Or,
Or meron pong plus 1
plus,
axis.
there you
1.
go, same, 180. Correct. So that will cancel out the astigmatism. Correct?
Yes po.
All right. Very good. Very good. So that would give you, therefore, what you have here, the external was neutralized by the internal. So now you understand the difference between internal, or let's do the last one, last example. Assuming I have minus 2.50 combined with minus 150, axis 90, and K readings of 44, 44. What will it give me, Irene?
Plano po.
Zero. Exactly. Zero, right? Because 44 and 44, zero. Okay, it's zero, guys. Zero. Not Plano. Zero. Okay? Because we're talking about, guys, just a correction. When we're talking about corneal astigmatism, from the word astigmatism, we don't say Plano astigmatism, correct? So that's zero. So you have zero. Okay? So you now correlate this to the total. And what does it tell you? Irene, what does it tell you?
Um, it's different po.
Okay, it's different, number one. But number two, by correlation, let's understand. Externally, zero. But my total has 150. Next question, where did this come from? Right? So, where is it from? Remember the formula, Irene. Remember this formula. I plus E equals T. Or E plus I equals T. Or T is equal to I plus E. Okay, use that. Where is this from?
From the internal po.
Very good. So this is purely internal. Okay? So this is purely internal. So your astigmatism in your manifest refraction is purely internal. And how do you address that? By giving soft toric contact lens. Because soft toric contact lens is good for internal. Okay. I'll give you last example. How about this one? Minus 3 combined minus 1. Axis 180. K reading 44 at 180 and 45 at 90. How much is this?
-1.
Very good. Minus 1 what?
Uh, at 180 po.
At 180. How do you record the AC?
Um, it's the flattest.
Okay, the upper cylinder axis, the flattest, which is,
Flattest is 44, so axis 180.
all right, very good. As you can see, this is minus 1, the upper cylinder axis 180. You correlate this here. What can you say?
It's the same po.
Very good. Once it's the same, your description now is the astigmatism of the patient is purely external. Is that clear?
Yes po.
Why? Because my K reading, which is my corneal reading, the corneal curvature, which is my external, is evident in the manifest. Right? As you can see, they are the same. Therefore, the astigmatism of the patient is purely corneal. In which, whenever it's purely corneal, the contact lens in mind would be RGP. Does that make sense now?
Yes po.
Should I explain more? You want more example? Are you already good? Any questions, guys? How about the others? Any questions on that? Okay. To sum it up, first things first, in understanding with the rule, against the rule, and oblique, you have to know where it is steepest. So, where is the greatest curvature? That is how you determine whether it's with the rule or against the rule. Look for the steepest or the greatest curvature. Where it's at is your determining factor. Okay? If it's horizontally, this is against. If it's vertically, this is with. Okay. If it's obliquely, then it's oblique. And then as for internal, external, or combination, meaning to say, let's give another example. Minus 3 combined minus 1, where I have this one, carrying of 44 at 180 and 45.50 at 90. How much is this? Minus
Minus 150 diameter
very
cylinder.
good,
Axis 1
very good, very good, very good, Joyce. So what does it mean? We are to correlate this to this. Are they the same? They're not the same, obviously. So you have a 150 external, and my total is 1. So somewhere internally canceled out this 50 externally by probably creating a plus 0.50 axis 180 internally, or axis 90 internally. So far, we're good. So meaning to say, this is not purely corneal nor purely internal. Correct? This is a combination. So far, so good. Any more questions, guys? Joyce, do we have any questions there?
So far none po, Doc.
None? All right. So there you go. None so far. All right. So there you go. Thank you so much, guys. We are done.
Thank you po,
Stay
Doc.
safe. Thank you. Stay safe.
Thank you, Doc.
Thank you,
Thank you,
Doc.
thank you, thank you, thank you, thank you,
Thank
thank
you
you.
po, Doc.
Thank you, thank you, thank you.
Thank you po, Doc.
Thank you. Joseph, yes.
Thank you
Yes,
po,
yes,
Doc.
Joseph. Thank you, thank you, thank you.
Doc, nasabi niyo po ba na we can have a makeup class for EOHs?
Yes, 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 hopefully. Are we gonna do it now or you wanna do it later?
If you're
So that
free
is
po now,
lunchtime.
Doc, para matapos
Ah,
na.
sure. Okay, okay. All right. So can we ask everyone to leave if you're not section A? Section A stay so that we don't have to create another